James, how are you today?
Good. How are you, Chris?
Good. Welcome to the podcast.
Yeah.
Beautiful day here in Redwood Shores in our office. So, James, before we get started, would love to just have you introduce yourself. Like, what's your background? Why are you so invested in Milvus? Why are you so interested in distributed systems? Tell us a little bit about you.
Also, hey everyone, James. Working in Mills for quite a while, like 5 years. Before I joined Zetas, I built multiple different scalable databases, including Cassandra and HBase. So I found it really interesting that original database is purely built for structured data. Then when I found the opportunity that there is that much of unstructured data, there must be a database that's built for it. That's why I joined Zetas and try to build a vector database for quite a while. And so far, it's a lot of fun.
Nice. So, just for everybody who's joining us on the podcast, I'm Chris Churilo, and I'm the VP of Marketing here at Zillis. So, let's just start with some of the basics before we get into Milvus 2.6. What in the world is a Milvus?
Milvus is a scalable cloud-native vector databases built mainly for unstructured data. So by the time we start from it, there is actually no definition of vector databases. So what we thought is we do need something that can manage all the vectors, store it, and efficiently search for all the data. That's why we built for it. And then after a while, we found that there are so many unstructured data, and you cannot even put it into a single machine solution. That's why we start to make a scalable solution, which is Milvus 2.0. It has been working quite well. Right now, it's its sixth major release, and could be this last long term version for. So it's yeah.
So, it's open source.
It's for sure open source. Yeah. The first day we built this product, we want to make sure that a lot of people can take advantage of it. Yeah. By that time, there are no options. That's why we decided to build it by ourselves.
Nice. And you donated to Linux Foundation.
It's a long journey. Yeah. First of all, we decided to do it by ourselves, but we soon find that under Linux Foundation, there is definitely a lot of other community we can work together, and people actually trust a project under umbrella because there are a lot of advantage, of course. Yeah, and Linux Foundation also help us to work with the community, help us to build all the rules and manage the community. That's why we decided to join.
So, it sounds like you get a lot of feedback from the community. Is that one of the reasons why you decided on the feature set that we're going to talk about with 2.6?
Yeah, I would say especially after large language model comes out, we see wide amount of usage, and we see different kind of use cases for sure, especially for RAG and a lot of use cases related to large language models. That's why we see we get a lot of input from the community. Those users are really trying to build cool demos and real world productions. Yeah, so for 2.6, I think the main goal is to reduce the cost and also make Milvus much closer to all the AI applications, because we see with a lot of different data, the data model for vector database is also changing. So we actually get a lot of feedback from the community. Like some people said, I do need vector embedding these. Some others said, I do need heavy search and I need a lot of functionalities similar to traditional search. So that's why we try to add different elements into vector databases to catering their needs.
So you mentioned that 2.6 is really about reducing costs. That seems like a strange thing for an engineer to worry about. So why are you focused on helping other engineers reduce cost?
Yeah, because the original goal for Mu was just to make it super scalable. During the last couple of years, we see that scales from billion level to 10 billion level, and now it's even 100 billion level. It works pretty good. But the challenge is with so much data, your cost or your machine usage also grows so fast, and not too much people could just afford of it. Yeah, so then we soon realized it's something called Jarvis paradox, which means the lower the pricing, the larger the use case you could say, and I think it's not only for vector database, but it's also for larger models. Let's see if all the vendors are just trying to reduce the token price. And when the token price is low enough, we could always unlock some new use cases. Similar things happens in the vector database industry. So with so many data, we believe that if we can reduce the pricing using our cutting edge technology, it can also help a lot of people to build their cool applications on top of all the unstructured data.
That makes sense. I mean, at the end of the day, no engineering team is going to get a blank check from finance. So we always have to be aware of cost, even if it's like the hot, project that the board wants us to work on. AI still is not going to get unlimited funds.
Yeah, I would also like to mention that if you talk about values, you would definitely see like transaction data or the original relation data. They have much more values compared to unstructured data. Although like unstructured data, we know that there are a lot of insights in it, but it's still huge. And to trying to find all the values into it, you need to be very efficient. Other than that, you actually pay much more than what you can get from all those data. That's why you also have to be like optimize on that, trying not only on the storage, but also on how the computation you spend on it.
So you're saying that vector databases are similar with like traditional relational databases where there's actually different kinds of data. So there's some data that's like more transactional versus some data that's more analytical. Can you maybe talk about like what are those different use cases so people can understand? Because I think in the relational world, it's pretty easy. Like customer orders are very transactional. But maybe in the world of vector search, what are the differences with those two paradigms?
That's an interesting question. So we all know that when you leverage AI, there are actually two stages. One stage is just to training all the models, which is converting all your data into intelligence or into a real model. And after you get this model, you actually apply those models together with your data, and you get the answer. That is what we call as inference, right? So vector database is actually working on both stage. On the training stage, we can leverage vector databases, trying to help those data engineers to find the data to fine tuning or training their models, which can save them huge amount of training effort and also time. That is what we call as a vector lake, because under that use cases is more often just interactive search. People don't have a lot of strict limitation on their query latencies or query throughput, but they care about the cost because we're trying to handle like billing level data. But on the other side, if you're trying to do reg applications, trying to do search applications, it's more on the inference side. So vector that directly talking to your customers, talking to some machines, then QPS is going to be very critical. Latency is usually going to be under 100 milliseconds because people don't want to wait for too long. Then under that case, data might be small, especially when you build recommendation systems or regs, but you have to be pretty much fast. So that's two different use cases for vector database.
That's cool. That's really interesting. And so if we consider those two different use cases, then that means we could actually add a semantic layer across all of our data. Is that what you're trying to go for?
Oh, yeah, that is like for a lot of like rag applications, or we try to build a semantic layer using vector database, helping larger models to reduce their hallucination. Yeah, but on the other side, like you also have a bunch of training data set, which might not be that valuable, and the data is huge. So you can run a lot of different machine learning algorithms on top of it, such as deduplication, such as doing similarity search to find some samples, helping you to training those models. So yeah, that is also a very interesting use case.
So I like your positioning of making sure that you can get value from both data sets because they are really important. But I can also understand why, the analytical data, yeah, you definitely can't afford a really expensive vector database to be able to help you with that. So that makes a lot of sense the way that you've kind of bifurcated that data concept.
Yeah, I think if you look at what we have in the industry, a lot of vector search infras, they're just trying to load all their data into main memory, which is the traditional way. We do that like back to 5, 6 years ago. We still have that options, but it's only for high performance use cases. But on the other side, it's just too expensive to load all your data into memory. Yeah, that's why for the last couple of years we spent a lot of time just trying to offload the data into your disk. That help you to save like 5 times, 10 times your memory and money. And right now, we want to do it further, not only on your local disk, but also you're using your remote storage. Instead of still caching something in your very expensive EC2, we're just using fully leveraged S3 and all the object storage that could further like reduce the cost on those interactive search use cases where latency is not really important.
So let's then talk about specifically with Milvus 2.6. So let's just talk a little bit about the tiered storage feature.
Yeah. Tiered storage feature, I think, is one step towards the final goal of our vector search. Yeah, we realize code storage is going to be very important, and a lot of people, our users, is complaining about. I'm trying to build a multi-tenant vector search use cases. I have huge amount of tenants. Not all of them are very active. But I still need to load all the data into some kind of caching, either it's memory or disk, which is like a lot of expensive for me. Is there any other solution for that? That forces us to think about how do we save those money for those data not actively used. Yeah. So the answers seem to be simple. Just need to push all the data down, all the way down to the object storage, because that's a cheapest solution we can find on the cloud. But the challenge here is the latency. How do we handle, because although those data are code, but sometimes you like one day you have to use it, and if you directly store everything to the object storage, it probably the initial code query probably going to take you a couple of seconds, which is not good enough for many of the use cases. Yeah, we did a lot of optimization on that, and we trying to leverage multi storage tier using memory, disk, and object storage. So for all the code data, it stores on the cheapest solution, and trying to caching all the actively search data into local storage. Yeah, and the best part for that is you can also do a pre-worm. So once you find maybe one of your tenants actually getting online, you can directly send a pre-worm request to Milvus, so we can loading all the data from code storage into worm storage, so help to increase the performance.
So can I use whatever index type I want and still take advantage of this tiered storage?
Oh, yes. So we do have multiple different options. Like you can use either IVF index or HW index together with the new tiered storage features. There is a special version index on those cloud, which is actually faster, I would say. But yeah, even for any kind of open source users, I think most likely the case will be good enough just using the open source index.
So if I can just recap, so you can use HNSW if you want everything just in memory. I can then use disk ANN if I want to put it on storage. But then further to that, with either one, I can use the new tiered storage capability. So I can, put stuff that I'm not going to be querying very often into cold storage. But yet, when I do query that, it's not going to take a really long time. You guys have built some optimizations that can take care of it.
Yeah, think it is just as a cache, because we in Milvus we just partition all the data into segments. If the segment is not active, and if you don't have enough cache or like either memory or disk, we just try to evict all the data to object storage. And when new queries comes in and we find this segment is actually necessary, we just trigger a load operation. I know like before 2.6, a lot of users actually play those tricks by themselves. So they're trying to do load and release by themselves to make sure that they have enough memory for serving. But it's error prone and also a lot of trouble to do that. So we decided to like directly put into Milvus, so people don't need to worry about it.
Actually, that's another form of savings, because you built that capability. They don't have to build that capability anymore. And you made it so that, it can not be error prone, that can actually work properly. So that's pretty cool. Mm-hmm. Let's talk a little bit about the compression or the quantization techniques that are new in Milvus 2.6.
Yeah, I think that's probably the most exciting part for 2.6. About 2 years ago, we talked to Jian Yang, who is actually a PhD student, and he actually write a paper in Sigmod. Yeah, we noticed the paper, and the quantization is named RabbitQ. So we did the test, and it's really I would say astonished by the results. We see great recall improvement with the same like quantization bit. That's why we tended to put into real work. Yeah, so we co-work with their team, implement all the algorithm, and also did some engineering optimization. And it turns out to be, compared to the traditional like product quantization, with the same data set, the recall just increased by 2 or 3%. So it's a big progress. And the most exciting part for the vector search industry is that during the last couple of years, we see more and more researchers coming to this space. Yeah, and we'll definitely like pushing this to pushing all the like research results to production, and that's also the fun part for building vector database, because you see a lot of new things every day.
Yeah, that's really cool. I mean, this quantization stuff is pretty amazing, and to get better recall is pretty phenomenal. Because basically, for those of you that might not be aware, the way that I think of these quantization techniques is I compare it to like raw data versus JPEG. Like when you do that conversion, you lose certain colors in your picture that maybe you're not really using in a picture. It could be like one little pixel has that particular blue. You can take it out and you can still see what that picture is. So it's kind of a similar concept, but much more exciting than
I would say
pictures.
the major trade-off in vector database industry would be the accuracy versus performance and cost. That's a triangle that you cannot like achieve like based on all three different perspectives. So yeah, so using quantization is trying to sacrifice a little bit recall or accuracy and improve the performance and memory usage. Again, like this is a great opportunity to help you to reduce the cost and improve the performance. Yeah.
So that's one animal, rabbit. So let's talk about another animal, woodpecker. So what is woodpecker?
As you may or may not know, like all of our products is actually naming after a bird. We when we start Milvus, we soon realized that data freshness is actually very important for vector databases. And for today, like if you're trying to build an agent applications or RAG, you definitely don't want to wait for like a couple of hours before your data is actually indexed. So by that time, the way we're solving that problem is trying to introduce message queue into our system to make sure that data can be ingested and searched immediately. We supported both Pulsar and Kafka, and put Pulsar as our like default settings. Yeah, I know a lot of people have some concerns of maintaining such a big stack, and we heard from the community that this is probably heavy and not good enough. So we rethink about this. For many of the other use cases, write latency is not the most critical part. So we can just try to build another cloud native Red Hat logging service and purely eliminate all the other dependencies of Kafka and Pulsar. So that's where Woodpecker comes. So it is used as the main Red Hat logging solution for Milvus 2.6. And of course, we saw great like write throughput improvement. It's much easier to maintain, almost no cost. Yeah, and we also saw it's a great opportunity to for other like infras to using Woodpecker as their Red Hat logging, because it's kind of like the common solution for all the cloud-based databases. So we're very excited about this.
That's cool. So that's another way to save costs. So you have less dependencies, but also data freshness is really important. And you have less, you don't have to have as many people, dealing with this stuff. So that's pretty amazing. But if I still want to use Pulsar and Kafka, because I've been using 2.5, is that still an option in 2.6?
Yeah. I mean, if it yeah, Pulsar and Kafka still have its advantage. First of all, it can be low latency compared to Woodpecker. Yeah, and also for many of the existing users, feel free to do upgrade, and we won't break the compatibility. Yeah, just for any kind of new users, you want to save your time and effort to maintain just another stack, trying to use Woodpecker will be your choice.
Nice. Very nice. Oh, okay. So, we're almost at time. And so I just wanted to give you a chance to maybe talk about maybe one or two more features that you think are really worth mentioning on this podcast. That's part of 2.6.
Yeah, one of the other exciting features I would say is data in, data out. When we start to build vector database, we thought we want to like purely split embedding generation and vector search, and directly focus on just the engineering part and leaving all the model part to those experts and who can train and doing all the inference on the embedding models. But during the observation for the last couple of years, people keep telling us you guys probably need to like integrate embedding models and re-rankings into the system because it makes our life much easier. Yeah, and I thought they're right. Yeah, but the way we do that is kind of like a little bit different from the others. Remember, we are a database company, so we do leverage user-defined function service. So we have multiple different like default integration. For example, you can directly do with OpenAI embeddings or Voyage AI, or maybe Google Cloud embedding service. Yeah, but other time you also have an option to write your own functions. So if you have your special like embedding service, even an in-house solution, you can just write a user-defined function. Yeah, and right now we cover both embedding and re-ranking, and we'll soon like have another user like a UDF service server. You're gonna see that the Mill is gonna support more functions in the future, and those functions actually give people a lot of flexibility to adding their customized logic into vector databases.
Okay, so that's really interesting. So I in 2.5 and previous, I bring the embeddings in to Milvus, and then I do my search, and then usually what I then return back to my application is not the embedding, but whatever it is that I'm ultimately trying to search on. But what you're saying is I actually bring in that data into Milvus, which you had a little bit of that in 2.5 with the sparse embeddings. So I bring in my data, and then I can either use one of my own embedding models or an OpenAI or whatever commercial product, and then it'll convert that embedding and then store that in both of those things into Milvus. So it sounds like a pretty good time saving, that we have here.
I think there are multiple savings here. First of all, the developer experience is much better, so you don't really need to worry about the APIs you are not familiar with. That is one thing. And the other thing is that with the new API, you can actually do a lot of pre-processing and post-processing on the data. So, which means maybe in the future you can directly throw a PDF into a vector database and implement your own chunking OCR logic without build this long pipeline. So that could make your life much easier to maintain multiple different infras. Yeah. And the other thing I would say is that we do have the potential to do all the embedding generations. So in the new Mills operator, we actually support to brought up a VLM, which is as an inference engine, or Hugging Face text generation like inference engine. So if you're using Kubernetes operator, you don't really need to worry about your embedding generation, and you have a default solution there.
Very nice. All right, and then one last feature that you want to just kind of give a strong shout out about.
Yeah, well, I think one last feature I would say is a lot of optimization on the Scalar search side. Yeah, everybody may know that we have BM25 supporting 2.5, and a lot of people really like it, and they ask for more. Like, can we just do Elastic compatible? My answer would be no. Like, Elastic have so many features, but we start to do that. Yeah, trying to add more features compatible with Elastic. One of the cool feature would be freeze match. In the 2.5, we do have match, so people can do a text match with a certain keyword. Yeah, but right now you can not only match with keyword, but you can also match with a short phrase. So it can actually helping you when you do regs. It can actually helping you to match the data in a more accurate way.
Nice. That's actually pretty powerful feature. So this sounds really worthwhile for people to kind of play around with. So everybody, please go ahead and download it. And then where can people find you, James?
You can find me anywhere on GitHub, on Discord channels. Yeah, you can also send me emails. We'd like to hear about a lot of feedbacks. Yeah, and yeah, I'm pretty much open to have a one-on-one session for anyone, any open source users. If you have any feedbacks or you have feature requirements, it's gonna be very, very valuable for us.
Cool. Well, thank you so much for your time on this beautiful Friday afternoon. And most importantly, thank you so much for all the contributions to this project. All right. That's it for today's podcast. And we'll actually have another chat with James in the near future.
Hey guys.